tak relevant. Alright. So, okay. Mungkin ambil lebih familiar. Alright. Okay. My slides are actually more than what I showed to you today. Kalau you nak slide dia, I boleh bagi lah. So I have to skip some of them sebab nak jaga masa ni. Alright. So, okay. Obviously, this is the last topic for today. And then petang ni kita ada technology episode flat. Ada ni main slot tadi. Okay, correct. I'll cover that one as well. So, okay, first of all, masking is a very hot topic, even for ORL, MX students or even ORL specialists. But jangan do not worry so much, because most of the time you will be audiologists who will do all the procedure. You baca je algorithm. But I know that some candidates who I met, they actually, feel suspend, they want to know more. Right? So I will not try to cover all sebab memang I rasa macam tak perlu sangat. You don't have to worry much about masking. Right? There are certain things that I will emphasize, but you don't have to know everything. Okay. So, okay, the concept is now here. Alright? We test hearing using headphones and bone vibrator. Betul? Air connection, bone connection. Alright, let's talk about bone connection testing. Alright, if you have bilateral normal hearing, alright, you put the bone vibrator on your right mastoid, measure BC threshold, it turns out to be 0 dB. Okay, that's fine. And then you test the left mastoid, bone connection threshold, also 0 dB. 0, 0. Alright, you get the same BC results most of the time. Why? When we do bone connection testing, it vibrates the whole skull. Kan? You letak dekat sini, alright? You present the sound. The sound will eventually arrive at the cochlea through the one head skull vibration. Bukan sebelah sini dia bergegar, all. Which means that kalau you ada, normal cochlea here, perfectly normal, sini you ada dead cochlea or profoundly lost. Alright, severely damaged cochlea. Normal cochlea 0 dB. You have bad cochlea here. Kalau you letak bone correction on the bad ear ni, ear with the bad cochlea or the one with the damaged cochlea, you akan dapat 0 dB juga. Because it vibrates the whole skull. The one with the good cochlea will give the response. Boleh nampak ke? Okay, it's very clear. Alright, so that's why bone correction masking is very logical to be done. Because when you do not do masking, you will get a false threshold kat sini. Faham tak? This is good cochlea, damaged cochlea, you letak bone kat sini, you dapat 0 dB. Tak betul. Because this response datang daripada the other ear, because when you present the stimulus through bone conduction mechanism, it vibrates the whole skull. Alright? So the reason to do masking is very, very logical. Right? Because the way we stimulate the bone cord conduction is through the whole skull vibration. Nampak? So kita kena buat masking. So maksudnya, we know that yang ni memang good hearing, this is bad cochlea, you letak sini dia keluar 0 dB, unmask. Jadi, kita kena bagi masking to the good ear, make it less busy, and then you can see the shift of the threshold daripada 0, 20 sampai no response at 70 dB. So that's the true BC threshold. It solves our problem in order to get the true BC threshold for the ear with the damaged cochlea. So the reason to do masking is very clear. It's very clear. Boleh? Are you still with me? Alright. Okay. Boleh? Okay. Air connection pun perlu buat masking juga kan, betul? Right. Kenapa kita kena buat Kan? Okay. Kita tengok air conduction, kita punya headphone kan, betul? You test left, you've got the threshold. You test right, you've got the threshold. Tetapi kenapa kita kena guna masking juga? Why? Because you test ear left right separately, it goes to the left punya external ear, middle ear, inner ear, right punya external ear benda ini, you tak kongsi yang sebelah sana punya, kan? Tapi kenapa kita kena buat masking juga? Kan? Kan you rasa benda ni biasa je. Alright. Kalau you are the beginners, you akan fikir, kenapa pula nak kena masking? Bone correction is very clear. It's the whole skull vibration punya issue. Alright. Unfortunately, I have to tell you, unfortunately, the reason why we have to do air correction masking, if required lah, dia ada rules of masking pun, I will cover that. Because any transducer, headphone ke, inside earphone ke, they will vibrate at high intensity levels. Faham tak? You pakai headphone, you bagi 20 dia tak vibrate lagi, 30 tak vibrate, 40 dia start vibrate, tak nampak? Bila dia start vibrate, berlakulah transmission of the sound to the other side through skull vibration. Boleh faham tak? Boleh faham So you bayangkan, you have normal hearing here, normal hearing. Yang ni sepatutnya dead ear, tak dengar sepatutnya. So you buat yang dulu, 0 dB air connection. Mungkin bone correction pun 0 dB, tak apa. You start to test the one with the dead ear, you bagi 40 dia tak dengar. Atau you start dengan 20 tak dengar, 30 tak dengar, 40 tak dengar, 50 dia start tekan the button. Faham tak? Right? Then you get the threshold at 50. Padahal hidden threshold dia 120, no response. So means that bunyi tu somehow dah travel to the good ear, so the response coming from the good ear. So how is this possible? Because vibration of the headphone. That's how the sound is transferred from one ear to the other ear. Alright? Which also means that katakan somebody in the world boleh come up with the design of the headphones that will not vibrate at all at 120 dBHL. Alright? Kita tak perlu buat air correction masking. Boleh faham tak? If you can come up with a headphone yang never vibrate at all, dia duduk je kat situ, it will never vibrate at all. You bagilah 80 dB ke 120 dB ke, if that transducer never vibrates, you tak perlu buat air correction masking at all. Sebab crossover tak akan berlaku selagi skull tak vibrate. Boleh faham Itu bezanya air correction versus bone correction masking. But unfortunately, any transducer, like what I mentioned to you earlier, whether it's inside your phone ke, headphones ke, when you start to deliver 40-50, they start to vibrate now. Right? Headphone, they start to vibrate earlier. It's a headphone, dia lambat sikit. Dia kena 70 dB baru dia betul vibrate. The one that we call IAA, Interval Attenuation. So, itu sebab dia. So, the point is that kita kena buat dua-dua, air correction masking and bone correction masking. The bone correction masking is very clear, it's a physiological issue, kan? Tapi air correction itu because of the technical issue tau. It's a technical issue. Headphone vibrate, headphone is a technical issue, device issue sebenarnya. Faham So that is the basic. So unfortunately belum ada lagi that kind of the headphone that will not vibrate bila you bagi at high density level. Kalau ada, kita kena beli. Ada, kita kena beli. Jadi tak perlu buat air correction masking. Kalau dia tak vibrate, the skull tak vibrate, bunyi tak pergilah from one ear to the other ear. Faham Sebab you bagi apa? You letak earphone directly to that ear. Mana ada bunyi tu pergi sebelah sana, kan? Betul tak? Dia betul masuk sini, kan? To that particular ear. Boleh faham Alright, so good. So I have 5 minit lagi, okay? Alright, so okay, so again, I bagi contoh tadi. So patient ni dia ada sepatutnya left side 0 dB AC, 0 dB DC, normal hearing. This one has profound loss, right? When you 120 dB, so you bagi bunyi 30 dB tak dengar, 40 dB tak dengar, 50 dB baru dengar. So kita akan ambil as a threshold. Cuma kita tengok ada besar gap antara left right. We believe that the crossover is happening. We believe that the skull has been vibrating, transmitting sound, then that response coming from the good ear. Kita ada indicator between ear punya differences. Faham bila berlaku skull vibration, because the headphone vibrates, the sound will transfer to one side to the other side. But along the way, some of the energy will be absorbed by the skull. The one that we call IAA, interaural attenuation, which is around 40 dB for headphone, around 50 to 70 for the insert earphone. So, when somebody wanted to come up with rules of masking, they have to consider the IAA, right? Right? Because if the IAA is smaller than 40 dB, so kita tak percaya bunyi tu, if the IAA is higher than amount yang kita bagi, kita percaya crossover tidak berlaku. Dia ada dua isu tau, crossover and cross hearing. Right? Okay. Example, IAA is something that the data that have been provided to us, it ranges from 40 to 80 dB. Maksudnya, some from one side can travel to the other side, but some 40 dB will be absorbed. Right? Contoh, kalau you bagi 80 dB here, alright, it's loud, 80 dB is loud. I'm sure that the sound will cross over because the headphone will vibrate. So 80 dB going here, so on the way to this ear, 40 dB will be absorbed, and 40 dB will reach here, and 40 dB is louder than the threshold here, 0 dB tadi. Mestilah dia boleh dengar. Faham kan? Faham kan? So that's what called the cross hearing. Right? The cross hearing. Masa you test the back side, you increase the intensity level. When it's high enough, dia akan cross over, absorb. And the remaining yang sampai tu is louder than the threshold, dan dia akan berlaku cross hearing. Alright? Boleh faham? So this is 0 dB, good hearing. Kalau you bagi 40 dB here, katakan dia cross over, tapi 40 dB semua serap, jadi tak ada bunyi sampai sini. So tak berlaku cross hearing lagi. Crossover berlaku, cross hearing tak berlaku. Because 0 dB kau sama. Kalau you bagi 50 dB, right, dia cross over, 40 serap, 10 dB sampai. 10 dB is louder than 0 dB threshold. So dia boleh dengar. So you are testing actually the sound from the better ear, not the real ear. Boleh faham kan? Okay. So the IA punya concept is the one that we insert untuk come up with the masking rule. I just go very quick to the masking rule. Okay. You can have my lecture notes later on. Okay. Ni contoh. Alright. PTA with no masking. Right? What do you notice? Of course, unmasked. Apa lagi yang you notice? Big apa, okay? Betul? Lagi? Yes. Shadow effect or shadow curve. Right. Remember, when I said to you earlier, when you are testing the lower side, tapi dia cross over, maksudnya telinga yang respond. So dia akan follow the response from this ear. So you get identical shape, but different stability. This is the shadow curve or shadow effect. Very famous question for masters or very famous. They want to say, okay, did you notice anything? Of course, you can say no masking, no mask symbols, but at the same time, nampak there's a big difference between left and right and the presence of shadow curve. Right? So what happen bila kita buat masking? Perlu masking kan? Betul? Kita masking telinga mana? Or noise kita bagi telinga mana? Alright, kita biasa bagi kat the better ear. So air condition masking kan? Betul? Okay. Alright, kita bagi so kita bagi noise to the left side. Then we want to determine the actual threshold for the right ear. So after masking, okay, nampak? What can you see? Air condition. Ini just example for air condition. Nampak? What do you see? Alright. So bila kita buat masking, what will be the outcome? The outcome would be the threshold for the tested ear though, the worst ear though, can be the same or worse. Now it becomes worse kan. In fact, now the severity has changed. Right? Before masking is severe. After masking it becomes profound sebab dia dah ikut 100. So nampak tak dah tukar severity. Right? Sebab tu kita kena buat masking to get the true threshold. Right? Yang feel black circle tu is the mask. Itu satu. You can see that the threshold change. Means that betul memang berlaku cross healing and crossover. That unmasked right memang datang daripada left side. So it is true that during PTA testing, the left ear is helping the right ear. When we do the masking, you have totally different result. It becomes worse dan lagi satu apa? Same apa? Okay, yalah, it can be same or worse. Apa lagi yang you nampak? Okay, tak apa. There's no more shadow curve. Result dia dah jadi lain dah. Dia tak ikut dah shape kat atas tu. Nampak So we are very confident this is the true threshold for the right side. Boleh. So ada lagi satu ni. Tak apa. Okay. So during masking, what do we do? Headphones, kalau air conduction, we identify mana satu telinga kita nak bagi masking noise, mana satu telinga kita nak test the actual threshold. Right? Biasanya we give the masking noise to the better ear, telinga yang bagus tu, because the better ear that will be helping the worst ear. Right? Okay, so and we need to follow the rules. Right? Untuk air conduction, you letak headphones. Alright? Identify which ear to give masking noise, which ear that you want to test. Kalau bone conduction testing, masking noise always kita bagi dengan headphones. Right? So you boleh imagine you want to get bone conduction threshold for the right mastoid. So right mastoid kat sini, noise kat sini kita guna headphones, bukan guna bone vibrator. Salah tu. In fact bone vibrator kita ada satu je. So kita deliver noise guna bone, guna headphones ataupun insert earphone lah. Faham? Alright. Then we do the needful ke apa ke. So, okay, this is the rules of masking lah for air conduction and also for the bone conduction. So basically for air conduction, we are comparing between ears. For example, unmask, we are comparing the unmask. So, right side, left side, you tolak air conduction between ears. Kalau dia 40 dB and more, kita kena masking. Okay? We go by frekuensi. Kalau semua beza 40 dB, semua kena masking. Kalau ada frekuensi yang tak cukup syarat, jangan masking lah. Tak perlu masking. Kita pilih lah. Bukan buat semua Alright, we go by frequency. Okay? To air conduction threshold. The first one, we compare air left, air right. First. Okay? Dan dia ada the second rule. Sama juga left right, maknanya is AC versus BC. Contohnya, AC right, BC left. Ataupun AC left, BC right. 40 dB and more kita masuk. Okay? Kalau untuk insert earphone dia besar sikit 70 dB lah. Ada suggestion for the higher frequency you go by 55 or 50. Alright? Tak apa, but that's how for the air conduction. Right? Bone conduction there is only one rule je. Air conduction and bone conduction from the same ear differ by 50 dB or more, kita mask. Okay. Right. Rule of masking mungkin ditanya juga kalau dalam exam mungkin ditanya juga. Basically you hafal je lah. Hafal je, dia tak ada cara lain Right. Hafal 10 minit sebelum kaibat, dia lagi ingat. Right. Banyak setengah juga. Okay. 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 I rasa I tak go into detail. You have other things working in your place, you bertanya sebab mungkin it can be too complicated So tak complicated sangat, takut you hilang pedoman lagi. Okay, so there is a step where audiologists know how to put the masking noise, put the tone, alright, and then they do the masking until we achieve what we call play 2. That will indicate the true threshold. Dan kita tanda kat situ menggunakan and it must be both. Alright? But there are cases where we cannot get the plate 2 after kita buat masking. These are what we call masking problem. Something that I will cover class ni kalau sempat tengok macam ni. Okay, we are looking for the plate 2 here. Fine? Alright. Tak apa? Okay, another contoh, this is before masking. Apa diagnosis kita kalau before masking? Of course, this is not complete, but impression dulu. Bilateral? Oh, okay. Mild, kemudian connecting gloss kan? Elongate, left right, dia tak garap, but that is our impression. Right? Of course, perlu buat masking tak? Perlu. Air connection perlu. Air connection, ingat tak? Compare left right. Perlu tak air connection? Tak perlu kan? Rule first pun tak perlu sebab you compare left right kan kecil-kecil tu 5 dB ke 0 dB. Kalau you compare left right, bone right, air left, air right, bone left sama juga. Tak cukup syarat. Bone connection perlu. Satu je rule dia. Air and bone from the same ear they differ by 50 dB. So kita akan buat according to what we have, kita kena buat which side? Bone connection. Which side? Both side. Belum dilema lagi. Both side yang betul. Remember, one rule je. You tengok, you identify mana satu unmasked left, mana satu bone BC left, right? Unmasked AC left, right. Then you based on that. Actually kita perlukan semua sebenarnya. Right? Very clear. Kita kena buat at all frequency left and right based on the rule. Betul? Dia satu rule je, each ear. Faham boleh faham kan? Okay. Clear kan? Kita ada satu je rule, bone correction masking. Alright. We compare the unmasked left BC and unmasked left AC. So you tengok semua fit, which is contohnya 250, unmasked left adalah 5 dB. Betul? Betul Untuk BC 250, unmasked left 5 dB. Betul? Unmasked left AC 40. Kan? 40 tolak 5 berapa? 35. Alright. 35. Kan more than 15 dB tu. So kita kena buatlah masking. Kan? Dan you kira macam tu untuk left right. Dia fit semua. They actually fit. Alright? So kita pun buat masking. So our initial impression dengan algorithm yang tak lengkap, we will get bilateral, mild to moderate corrective loss. After masking, nampak? Tadi it's supposed to be bilateral kan? Now? Okay, kita ambil for the left side dulu. Left side apa? Okay, alright. Mind apa? Corrective dia sensory. You kena tahu nak tengok mana So kat atas tu. Yang ni left. Nampak my left here. Left, yang ni right. Okay. So bone for all left still maintain dekat atas. You have snippet okay. It's a corrective loss for the left side. What about for the right side? Set very clear. Bila you buat masking dia turun, nampak? Semua turun dari 250, daripada 10 become 25. Alright? Daripada 500, daripada 10 become 35. Nampak dia turun. So now we believe that this is the true threshold. So for the right side is actually sensory neural loss. So salah diagnosis tadi. Kalau kita tak buat masking, this is the problem. You cannot really determine the actual type of hearing loss, the actual type of severity of hearing loss. But so the masking kena buat. Why with this? Right? So another example. Okay. Diagnosis. Right side. Right? Good. Mild sensory neural, betul perlu sebab bone ni memang dekat lah. Tak ada 15 dB pun. So kita boleh ambil terus. Tak perlu buat bone production masking for the right side. Boleh faham ke? Dia tak fit the rule. Kan? Okay. Left side perlu buat masking tak? So you nampak kan besar kan? So kita tertanya-tanya what happened after masking. Tapi kita kena buat masking. So what happened? Kita kena buat. Alright? So kita buat bone production masking. Alright? Oh, okay. So actually banyak masking kena buat sebenarnya. Air production pun kena buat, bone production pun kena buat, tapi cuma the left side sahaja. Alright? Now you understand kenapa Alugis makan tengah hari lambat kan? Ataupun keluar lebih awal kan? Alright? Nampak? Okay? So kita kena buat. You can see, kita pun by frequency, by ears. Kan? Kita semua kita buat kan? Alright. So, what happened? Okay? Nampak? Okay? Alright? You tengok ini. Sebelum kita buat masking, ada possibility tak for the left side tu mungkin produktif? Ada kan? Sebab kita tak nampak bone ni dekat mana. Kan? You boleh kata okay, right side tu confirm sensory, tapi left side ni produktif pun boleh, sensory pun boleh, mix pun boleh kan? There are so many possibilities. Kalau you tak buat masking, memang your diagnosis memang tak betul kan? So bila you buat, alright. Okay, now it becomes sensory. Fine. So you can see they go down. You nampak VT there. Right, means that the cochlea is badly damaged. You can even perceive artery secession. Right, so it's a very nice sensory neuron. Not just that, the shadow curve also disappears. You know, the unmasked left is very similar to the unmasked right before the masking. Apa? Shape sama, shape je tu, kan? When you do the masking, dia dah jadi lain shape lah. So the presence of the shadow curve really indicates that the cross lyric occurs. Sebab tu you buat masking, you want to get the true threshold. Macam mana? Bukan? Okay. No, bukan. Dia VT. Sebab you have to go down. Bila ada VT, you jangan consider airborne gap tu. Dia tak betul. When there is a VT in the nose, airborne gap tu tak betul. Faham kan? So you tengok, kalau you consider airborne gap dekat 250, it's a 25 dB airborne gap. Nampak macam ada produktif, betul? Tapi ada plot VT there. Means that I stop bila dah ada VT, patient tak dengar. Dia tak dengar bunyi. There is no sensation of hearing. Cochlea is badly damaged. All he can hear is the sensation of vibration. Bunyi bergetar. Sorry, dia dengar getaran, bukan bunyi. So bila dia nampak VT, the airborne gap there is not trustable at all. Ingat itu, right? So it's actually sensory neural loss. You got bilateral sensory loss with different severity. Alright. So this actually from the real case juga, kan? So kalau I buat Weber, what will happen? Kalau I buat Weber, okay, Weber test. Alright. Okay, audiometric Weber test. Alright. I buat, okay, I akan ambil unmask punya threshold. So the best threshold 35 atau 500. You know, 500 Hz. The best BC unmask is 35, betul? Kan? I present at 45 or 50. I letak sini. And ask the patient, dengar bunyi, dengar. Left or right? They can easily tell you. Kalau kes jenis sepatutnya bagaimana? Bagaimana? Yes, memanglah. Because that's the ear with the better cochlea. Alright. I tukar, I buat 250. I repeat the same Weber test. Okay. The good unmask 20 dB, betul? I present at 30 dB sebelum the VT. I present, I do it in 10 remember, so patient boleh dengar. 10 senyap semua. Alright? I letak. Alright? If you are worried, ni airborne gap kot. Kalau airborne gap, katakanlah dia tu conductive, dia pergi mana? Dia laterals to which ear? Kalau dia tu conductive at 250. Dia laterals to which ear? Left side lah. If that is a true airborne gap, dia akan pergi to the left side. Bila you buat, it goes direct to the right side. So tak ada pun airborne gap. So that airborne gap yang ada VT tu memang you jangan percaya. Alright? You boleh percaya kot? Alright. Nampak tak? So this is good eye contact. Memang dia laterals to the right. So that's airborne gap tu bukan airborne gap. Not trustable at all. Boleh faham It's a very simple test. 2 saat je. Lebih sikit kot untuk buat audiometrik variable test. You dah ada moderator, you letak je. Okay? Nampak Dan in fact patient ni pun memang tim type A bilaterally, tak ada masalah pun. Right? So we don't have to worry that airborne gap at 250 tu. We don't have to worry. Okay? Boleh? So, I rasa macam dah ambil masa lebih. So, ada something yang I nak beritahu tapi mungkin sambung kemudian web. So, mungkin kita stop dulu. So, before that, any question or kalau you nak tanya? Sorry.
Shadow curve. I don't macam air ini yang spesifik dulu. Air to air or air to.
Okay, do not confuse yourself quite a lot. Kita go air and air saja.
Because the second PTA tu tak ada flat shadow curve lah kan.
Okay.
But require
Okay. Betul. The shadow curve question is very famous among ORL specialists. They will ask you, but for audiologists, sometimes kita tak kisah pun ada shadow curve ke tak. Kita tengok rules dia apply ke tak. Kan, sometimes you tak ada shadow curve, tapi you still kena buat masking because of the rules. Kita orang jarang sangat tengok shadow curve lah. But shadow curve punya soalan is very famous. Dan biasanya they expect air versus air. Tersebut boleh juga tapi it will complicate the matter more lah. Right? So, boleh macam tu. Alright. So, boleh? Okay, alright. Thank you. Ada soalan lain ke? Okay, I think that's it for me. Okay, thank you.
Ladies and gentlemen, our lunch break has finally arrived. Our break time is 10:30 to 8 at 2 p.m. Lunch is provided at the hallway. Please help yourself. We will be grateful if all of us can keep on time for the having session. We will see you again at 2 p.m. Kindly be informed, we provide Wi-Fi password at the registration counter and outside. For now, we have technical issue with our Wi-Fi. And kindly register for evening session at the registration counter and the hall at 2 p.m. On your way out,